Hello and welcome to lesson 2 of week 3. In this lesson, we are going to look at how to clean and prepare data. My name is Mildred. Now, when data contains duplicates or missing values or inconsistent names or spellings for the same value, or we have incorrect data formats, the data is of poor quality and it means we have bad data. And bad data is worse than no data. And we have to find ways to handle all of these problems. Now, in this lesson, we are going to go through the basics of handling these problems, and in our live web conference, we are going to go deeper. Now, when we want to handle missing data, we can use Numpy, which is not as efficient, but I'll show you how to use Numpy, and then we switch back over to Pandas. So Numpy will represent numeric data using NP. So let's import Numpy as NP. So Numpy will represent missing numeric data using np.nan like this. Okay, so let's say we have an array which is equal to np.array. Let's have 10, 20, np.nan 40, right? So this np.nan represents a missing numeric data. We have functions that we can use to detect missing values. Let's say we want to use isNaN. So we'll say print np.isNaN and we'll pass in the array. So let's find out whether we have empty. So we have 1, 2, 3. So this will return a boolean true. This will be false, false because it's not none, true, false, or something like that. So let's run this. So we have false, false, true, false. That's what we expect. So we can also have nan mean, and we'll use this to return the mean of this. So let's say this np.nan mean like this, and when we do this, we will return the mean of the numbers, which is 3.33. We can actually change the nan to number, and maybe want to replace the empty ones with 0. We can do np.nan to num. So let's say np.nan to num, and we'll put the array, and we want to change the nan to 0. So this is how we can handle missing in Numpy. So let's print this out. I'll clear here so you can see it clearly, and we have 10, 20, 0, 40, and then we can have the median. And so instead of nan mean, we can use nan median. So I'll tell you something about the median and the mean. Sometimes when we have missing values in data sets, we can fill in those missing values with the mean of that column or the median of the column. And as we go deeper, I'll tell you when you want to choose the mean and when you want to choose the median, and why you choose mean and median in different situations. Okay, so we'll do the median to ignore nan, and then I'll print that, and the median is 20, the median number, something like that. Alright, so we know that Numpy does not track rows and columns, and Pandas is better for real data sets. So when we use Numpy most of the time is when we want to do a lot with arrays, and we know it's faster than the Python array. But let's switch over to using Pandas to handle missing information. So we import Pandas as speed. Now for Pandas, we want to load from a CSV file. I have a CSV file here called employee-data.csv. So for this data, I'm going to import this, read this into a Pandas data frame, and we're going to use the data that we have here to look at how we can deal with missing values. So from a glance, you can see that some of these rows have missing information. For Pandas, there are different ways that Pandas supports an empty cell or missing data. We have nan like this, not a number. We have none. We have nat, not a time, like this, for datime items. So let us start. Now we'll start with reading this data set there. So I'm going to say df is equal to pd.read csv employee data.csv, right? So once you load the data, the next thing you want to do is to inspect the data. You want to look at the head, describe the summary statistics, or you want to look for missing values. Let's start with how we inspect it. Let's print out the head, df.head. We want to print out the first 3 rows, so we can see the head, the first 3. We have the columns to be ID, name, age, department, salary, hire date, email, city. We can actually look at the columns if we want to know the columns. So whenever you have a data set or you have a test for you to read a CSV file, you have to read this file, inspect the file to understand what the file is about before you begin to work on this. There are many things we want to do with this data. First of all, the columns, maybe the salary column, we want to make it numeric and remove this $sign. We want to look at the city. We have New York with hyphen, new and New York, and we have New York with space. We might want to do this to have the same kind of spelling, to remove all of the hyphen, replace with space or things like that. And then we'll look at where we have missing values, like this age. We have none here. What do we do with this? So we want to look at what we'll do with this. And then we have something we call outlier detection that we will look at later on. We can look at it in basic form, but it's a whole topic that actually can affect your data point or the analysis you are doing, or your results or conclusions from your analysis. And so let's first of all look at summary statistics. So here we can say we want to print df.describe, and when I run this, we have the mean count is 8, age 7, so ID 8. When we do summary statistics, it only deals with the numeric column, so for ID and age. So it gives us the standard deviation, the marks, and the different percentiles, 25, 50, 75, 5, and then the max and of the ID and then of the age there. Now we want to check for missing values. For you to check for missing values, you do df dot is null dot sum. So let's get the sum of all the missing values here. So we have ID, no missing value, the name column, no missing value, age, we have 1 missing value, department none, salary has 1, hire date, email, city. So we know we have a missing value in salary, we have a missing value in age. So how do we handle this? Since now we know where the missing values are in salary and in age, we know the names of the columns that we have here. We want to start handling the missing data. So the first one we'll handle is the age. So let's say df age. So whenever you do an operation like you handle missing data, there are different arguments you can pass in that can either define whether you want to edit the original or you want to create a new data frame from it. So when we do df age, we want to fill the empty. So we use the fill any method like this, and in the pair of parentheses we will specify that column that we want to fill and what we want to fill it with. If we want to fill it with the median of the ages or with the mean of the ages that we have, so I'm going to use the median. So I'll say df age dot median like this. So if I wanted to edit the original, I'll just use in place is equal to true, otherwise it creates a new. Okay, so I can do in place equal to true. So we have for the salary again, we have 1 missing, and let's do df salary dot fill any, and then we fill it with, let's say 0, and in place also true, something like that. Now we have handled the missing data. We have missing in age, missing in salary. We want to clean the strings. Now when we do, let's print df.head. I'm going to comment this out before I run it. Now when we look at this string like salary, if we want to clean this, we want to remove $sign, we want to remove this hyphen and maybe replace it with a space, or we want to replace a comma with a space in the case of this salary too. So we want to clean up the strings. So let's do that. I'll remove this now, comment this, I won't comment that, and then I'll say df. So the name column, we want to strip that string. So we'll say df name is equal to df, and we'll say the name column dot is a string dot, we want to use the strip method. So we want to strip spaces. Then for the city, we want to remove the hyphen and replace it with a space. So we'll say df city is equal to df city dot string dot replace, and we're replacing the hyphen with just an empty space like that. Now we want to look at the salary and we want to remove the $sign, right? So we'll say df salary is equal to df salary dot string dot replace, and we're going to be replacing the $sign and we're replacing it with empty quotes. We can add the argument regex equal to false, all right? And then for the salary again, we want to remove this comma and make it an empty. So I'll just take this and I'll paste it here, and I want to place the comma with nothing and regex equal to false. So we have done the loading the data, we have inspected the data, we are handled missing values. Now we are trying to clean up the strings. So the next thing we want to do is to convert data types. Like the salary we have is what of type string. We want to convert this data type to a numeric, and in pandas we use pd dot to numeric. So let's say df salary is equal to df salary. So say df salary is equal to, let's do pd dot to numeric df salary errors is equal to os df hire date. So let's change the date column here. We want to make it to date time. So we'll say pd dot to date time. We'll have df hire date, and let's say errors equal to os. Now what else do we want to change? Let's look at the departments. Let's give it a type, and let's make the department to be a type called category. So let's say df department equal to df department dot as type, and we'll have this as type category. Okay, now we have done all of this. We have handled missing data, we have cleaned up the string, we have converted data type. We want to handle duplicates. We know from this data here that Frank has an email bobexample.com and Bob has bobexample.com, and we don't want duplicates in this email column, we want it unique, so we can handle duplicates also. So if you are supposed to have a unique column where all the data points are unique, so you handle duplicates. So we have different ways we can handle duplicates. You can either want to drop the duplicates, right, or you want to choose other ways to do it. We're going to look into professional details on the kind of decisions you have to make or you can make. So let's say we want to see if it is duplicated. So say df dot duplicated like this, and then let's say df is equal to df dot, let's drop duplicates, and then subset is equal to, so we are dropping the duplicates in the email column, email like this. Now the last thing we are going to look at is outlier detection, and we have different quartiles when we did the summary statistic, where you can look at quartile 1, quartile 3, and then you get quartile 3 minus quartile 1 to be the IQR, and then we now use that to look up for the outliers to say that if their particular column is less than a value. But let's not go into the statistics for now because it will get you confused until you understand this. So we'll not deal with the outlier detection. But now that we have done all of this to clean, let's check the info again. So we'll say df.info, df.head, and let's see what it prints out now without having all of the missing values anymore. So let me clear here, and so let's run. So we have drop duplicates. Do you mean drop duplicates here? So spelling error. So we have that now. So now we have index 7 entry 0 to 7. We have all of the columns here, and we can see the higher date, non-null, date time. So we can see we've changed these data types here and from the info that we have now. And let's print out the head. So it's a print out, and so we have this. So we can see that where we had missing values or NA before, it has been changed. Look at the salary column. We removed the $sign, we removed the comma, we've dropped the duplicate row for the email, and then we've changed this New York. See how we've changed that. You can also change the capitalization if you want. That is what we did here. So when you inspect like this again after you have cleaned, and continue for further cleaning, because all of these can affect your analysis and what your final result will be. Outliers can throw your data points off, missing values can throw them, okay? And so these are the ways you will clean data, and then you will prepare the data and have a clean sample. You can actually export this to CSV to have a clean CSV sample that you can now just go straight into data analysis, and all of these fields we call data exploration. And so in our live web conference or in future lessons, we are going to look deeper at outlier detection and deeper at why we make certain choices of trying to fill in with the mean or with the median, or why we drop duplicates at some point, or how we're going to handle outliers or fix an outlier value. Thank you, and see you next week.